Okay, welcome back from lunch. It's 2 o'clock. Time to settle in. It's like kindergarten, right? Welcome to the second paper session, which is called Focus on Interaction. We will have 2 long talks, 3 short talks, be just over 90 minutes. And if you could grab a seat and welcome our first speaker, Joyce from the Exploratorium, who's going to speak about comparing tangible and multi-touch graphical user interfaces for data exploration in a museum exhibit.
Thanks for coming back from lunch. That's always good to see. I am new to this conference, and I'm still getting a sense of the community. So with a show of hands, who here has worked with a museum or at a museum? Wow, that's great. I feel like I'm with my tribe now. So I work at a museum. I work at the Exploratorium, which is a museum of science, art, and human perception in San Francisco, a convenient 45-minute train ride from here in case you have any free time after the conference. And at the Exploratorium, our mission really is to try to help people come to a better understanding of how the world works by really encouraging them to ask and answer their own questions. We build almost all of our exhibits in-house. Many of our exhibits are hands-on interactive experiences which allow visitors to really directly experience, directly investigate a cognitive phenomenon, like how do you feel when you drink out of a toilet, a physical phenomenon like a tornado, and biological phenomenon. So we are actively trying to support hands-on learning, and we're also trying to very much actively support visitors in learning from each other. So many of our visitors come not alone, but with each other. So the learning environment is a very social one at the Exploratorium. So when many people think about the Exploratorium, they typically think about exhibits like the tornado one, where people get a chance to directly manipulate the phenomena they're exploring. But more recently, we're looking at a different kind of learning experience for our visitors. And mainly this is motivated by the fact that science has changed. It has entered into the land of big data. So practicing science, especially the biological sciences, especially the environmental sciences, really involve scientists in dealing with petabytes of data. And we want to bring that experience to our visitors now. We want them to come to an understanding of the world by exploring large, authentic scientific data sets. And that's why I'm here amongst you today, because we're trying to see whether there is a place for TEIs in providing that way of really getting people to explore and engage with big scientific data sets. And there are various reasons why we're interested in physical interfaces. For one, physical objects they're familiar. We know how to manipulate them, so it may ease usability. Physical objects are familiar and concrete, so they could potentially bridge the gap to the more abstract, the more unfamiliar world of digital scientific data. And TEIs may also offer us an opportunity to really design more playful interactions to promote engagement. And this is incredibly important in a place like a museum, which is a free choice learning environment. So if someone isn't engaged, that person, they're not stuck in the classroom, they're going to just turn around and leave. And finally, we're interested because at least the literature has suggested that TEIs will be very good at encouraging multi-user interactions. And we like that because a place like the Exploratorium is a very social place. So here are all the reasons how TEIs will save the world. But when you actually look at the empirical evidence, it's quite mixed. Sometimes it helps usability. Other times it confuses people. Yes, it can encourage multi-user use, but so would a large multi-touch GUI. So what really is going on there? So the question for us came down to how can we design a tangible user interface that can help our visitors really engage with and explore scientific data sets. And in the context of a very traditionally hands-on science museum. What I like to do is I like to play a very short clip of the exhibit that we put together that was really one of our first experiments, our first forays into using a physical interface at an exhibit. And this work is really a collaborative effort among scientists, data scientists, oceanographers, artists, designers, education researchers, museum professionals, so really a whole bunch of people coming with very different expertise from the Exploratorium, from UC Davis, and from MIT. And the study that I'm going to talk about was really made only possible through the very generous support of the Gordon and Betty Moore Foundation. So here is the brief video, and it's here to kind of give you a sense of how the exhibit works, and also to give you a sense, if you've never been to the Exploratorium, the larger context of the museum.
This piece is called Plankton Populations, and it's a piece that we did that shows the populations of plankton around the world's oceans. One of the things that was important for me as the interaction designer on the piece was to find a way to make this giant screen something that works in the context of the Exploratorium. So we first started with size. We wanted it to be large enough that we could have a social experience around the table so that visitors could gather around the table from different angles and talk to each other about what they were seeing. And what we're looking for at the Exploratorium is a more hands-on exploratory experience.
My lab collaborated with the Exploratorium to create this plankton exhibit. We spent a while looking for suitable data sources, and the data set we settled on was called the Darwin Project at MIT. They have a model of how plankton grow and survive in all of the world's oceans. And they've simulated this on supercomputers with data sources from NASA and with satellite imagery and other climate supercomputer models. You put this lens object on the table and it shows you what a microscopic view of a drop of water from that location would look like. So it's an alternate visual representation of the data.
And as you move these rings around on the table, you can see what kind of plankton inhabit the ocean at that location. If you want to know more about the types of plankton that are swimming around within the lens, you can open up this guide, and the guide tells you more information about the plankton at that location. So what we see here are 4 main population groups of plankton. Purple are diatoms, blue are dinoflagellates, the green are Prochlorococcus, and the orange are Synechococcus. You can also see that there's a timeline here that's showing time passing. So this model shows the plankton populations as they change over time.
So here is one of those physical rings. It moves across a multi-taction table that's capable of detecting finger touches, fiducials, blobs. And you can't see this, but there is an infrared reflective fiducial that's embedded in this glass. You can't see it, but the cameras of the multi-taction table can, and that's how it is figuring out where the lens is on the table. So this lens, believe it or not, was incredibly difficult to design. It was incredibly expensive to make, and the question came up, what does this really bring to the table, so to speak? And to answer that question, what we did was we did a comparative study, and we designed its virtual counterpart. So here is the virtual ring in action. So it's very much like the physical ring. You can move it about. It's the same size as the physical ring. You could position it over a location on the ocean, and the phytoplankton image, the view will show up. You can also open up the guide, which will tell you a little bit about the 4 major phytoplankton groups that are featured. The designer went as far as to create a slight distortion in the virtual lens to mimic the slight distortion of the physical lens. So we collected 2 different types of data. We collected observation data, where we were trying to record people's naturalistic behavior at the exhibit. So at the beginning of the day, we would cordon off an area. We would put signs up saying, "You're being videotaped in this area." And then we put microphones around the perimeter of the exhibit to record their conversations. We used an overhead camera to record what they were doing at the exhibit. We also recorded their screen interactions. So over the course of 6 days, 4 hours each, we collected 12 hours of recordings for the physical ring situation and the virtual ring situation. And then we looked at the videos and we systematically sampled every 6th visitor who stepped up to the exhibit. Completely different set of days, completely different type of data. We also asked pairs of visitors to come and try out the exhibit and to talk to each other and to us about what they were thinking, what they were feeling, what they were trying to do, what they were saying. And we also asked them, we recorded what they said to each other and to us, and we also captured their screen interactions. So for the remainder of the talk, I'm going to primarily draw on the observation data. And these are just, in the interest of time, just some of the findings. So remember, we really were hoping that these physical rings would better engage people. So did that really happen? So there are different ways of thinking about engagement, and there are different ways of measuring engagement. One common way of doing so in the museum field is to measure holding time at an exhibit. So remember, this is a free choice learning environment. If someone's not interested, they're turning around and they're leaving. Was there a difference? Yes. There was a difference. This was statistically significant. More people stayed at the version with the physical rings than the virtual rings. But let's unpack that a little bit. So we looked at how many people touched a ring. And a majority touched, in either situation, they touched the ring. Now, if we looked only at the people who touched a ring, what was their holding time? No difference. So what is this saying to us? I think what this is saying to us is that these physical rings were really good at initiating the engagement, but they weren't necessarily better or worse at sustaining the engagement. So let's look at the nature of that engagement. So we were hoping that these rings will get people to really explore that data, to go in there deep and look at all the data parameters. So did that really happen? So we looked at this in different ways. We looked at the number of locations they stopped at to look at phytoplankton. We counted those, and then we looked at their distribution. No difference when it came to the number of stops, but there was a difference when it came to their pattern of stops. So the physical rings, there was a much larger search area. With the virtual rings, their stops were much more tightly clustered. And when you think about it, this kind of makes sense, because with a physical ring, you pick it up. If you're in the Pacific Ocean, you want to see the Indian Ocean, you pick it up and you move it to the Indian Ocean. With the virtual rings, you actually have to drag that ring all the way across the map, or find another virtual ring that so happened to be kind of close to where you want to explore. So far I've only talked about the observation data. Let's look at the think aloud data. Did people talk about the different data parameters that were part of the visualized data set? And when we looked, we found no difference. So what is this saying? It seems to be saying that when it comes to thoroughness of use, thoroughness of data exploration, the physical rings didn't really buy us very much, except if you wanted to really cover a large area, this would help. So finally, did the physical rings afford social interaction? And there are different ways of thinking about social interaction. We thought about it in the first way, the simplest way, which was, were they at the table with other visitors? In both cases, very high. So definitely in both cases, it's a multi-user exhibit. But there was just slightly more visitors who were at the table with the physical rings with other table. So definitely more opportunities to have productive social interactions. But did those productive social interactions happen? So we listened in on what people were saying to each other, and we listened for on-topic talk. Did they talk about the data? Did they talk about the plankton in any way? And we found no difference. So if they were at a table with someone else, they were equally likely to talk about plankton whether they saw the physical rings or whether they saw the virtual rings. So let's look at what about sharing of rings? And this was a little surprising to us. About a quarter, in both situations, about a quarter of the visitors shared, like they used the ring together, they talked about what they were seeing with one ring together. But for the most part, they were really engaging in parallel play more than collaborative play. And in some ways, it kind of makes sense because the way we designed this is my own little portal into my own little microscopic world. So I think what this set of findings is trying to say to us is that, maybe physical rings can give more opportunities for productive social interactions, but designing for those productive social interactions really goes beyond whether it's physical or virtual. So I always get this complaint. I work as an evaluator at the Exploratorium, and I always get this complaint because when people ask me, well, is this one better or worse? Should I use this or that? The answer is always, it depends. And so it depends. Really, when it comes to using TEIs, I think there are subtleties in the design. And that what we found out through these studies is that for certain situations, if you're having a real problem getting people to get over that first hump of engagement, maybe we should consider using a TEI. If there's something about the need to encourage people to explore over a large space, like a screen real estate, yeah, then it becomes important. If you're having problems attracting multiple users, yeah, maybe it becomes important. But whether you use a TEI or not, these are just some of the factors, and we're continuing to, as we push to create other exhibits that allow people to really explore and dive deep into scientific data sets, we'll be kind of trying to extract and maybe generalize from some of the initial findings that we collected as part of this data. So come by the Exploratorium, and thank you.
Okay, do we have any questions?
Really interesting findings. I wonder whether people have become so familiar with multi-touch that they're not initially frightened of going to use one. My question is whether you looked at turn-taking, that when you've got a physical device, is it easier or more difficult to grab that than a virtual one when you're waiting to have a go? Because I know in a museum context, sometimes you can be waiting for too long because someone's got hold of it. It's harder. So did you look at that at all?
We did do some of that analysis. So there are always 3 rings, whether they're physical or virtual, on the table. And we looked for behavior such as territory, protecting the ring or like fighting people off, and we really didn't see a difference between the two. I was a little surprised because I thought it would be much easier to protect a physical ring, but maybe our visitors are just very aggressive, but with a virtual ring, what we would see is this kind of behavior. So, yeah, you see it, but it comes in a different form.
Hi there, Paul Stromer from Queen's University. You did not say it, but it was sort of implicit that the virtual rings did not have any physics model. So you can't flick them over the area. And I was wondering if that was an explicit choice or whether that just happened, and what differences you would expect it would have made if it would have had a physics model.
That was actually at least a month of discussion with the design of this, because one of the developers who worked on this exhibit actually worked on another exhibit that had pucks. And what happened was it became a game of air hockey. And so we worked really hard to get just the right amount of friction on this so that you could still kind of move it, but you could not play air hockey with it.
I'm just going to switch to the right side.
I was just curious if you quantified what ages of people were more engaged by the physical versus the touch.
Yes, so that's actually in the paper, and that was something that we had questions about because there has been a lot in the literature about young kids being really attracted to physical things because they're just a lot more accessible to them. We actually found no difference, which at first is surprising. It's one of those duh moments. It was originally surprising, but then when you look at the table and you look at where the young kids come up to on that table, it's like up to here. So they don't know that there are physical rings on the table until they're already at the table, which is actually a good thing for us because phytoplankton, we're not expecting young kids to really engage in phytoplankton. So, we could talk about tangible versus virtual, but in some sense, it really sits in the larger design constraints, the larger design environment of the exhibit, and that's something we took care of within the physical design of the exhibit.
Okay, we have time for one more question, and then I encourage everyone else to contact Joyce in the break.
Okay, hi, I was there yesterday, and I played with this. And
Great.
It's wonderful.
Thank you.
It has a great feeling. I wanted to ask you if you considered having more types of objects with different form, having maybe texture as an element in the design, having some affordances of turning, or kind of bringing the TEI advantages forward.
We talked about it a little bit with this, but we felt that the data itself was already, so many things were happening with the data and how it was visualized that we didn't really play as much with the design of the physical object. We are now currently working on a different data set, and those things have come up again, in addition to the question of, Joyce, come on, why are we doing this? So we are thinking about things like having a boat. So the data set is of the migration of marine animals. And so we are thinking of having different types of boats that collect different types of data to kind of mimic what actually happens in science. One of the tricky things about especially the Exploratorium environment is that you don't want the objects to be too interesting. Otherwise, it becomes about the object. So there was even conversations with this about having this look really steampunk and maybe having some jewels in it. And the first response was, no, it's going to disappear in the first 2 days. And now with the boats, the argument is, no, people are going to play Battleship. And no one's going to look at the data. They're too busy, I-52, oh, darn, you sunk my battleship. So, so it's tricky, and I think that's why it's so important, and that's why I think we're so lucky at the Exploratorium that we get a chance to do all this iterative prototyping to see how people respond to these really kind of specific objects that connote different things to different people.
Great. Can everyone give Joyce a hand and for a great talk?